this, right? So this one is going to be RMO 2004, problem number 2. Okay. So we have a cube. Positive numbers. Wait, is it integers or probably integers? Yeah. Positive integers written on faces. Okay, so you know what faces are. There are 6 faces, right? Written on faces. On each corner, you mean no vertices, eight vertices. On each corner, the sum of the faces, sum of the numbers on the faces. So at one corner, you will have 3 faces meeting there, right? I'll draw a picture, but is written. Okay. And that total sum is sum of the numbers is 2004. Sum of the numbers on the faces is no, not on the faces, right? The corners. On the corners. 2004. Find the sum. No, find possible sum plus on, sorry, faces. Hmm. So think if the question is not clear, tell me.
Sir, in each vertex, sum of 3 faces will be written, right?
Yes, because for each vertex, for each corner, each vertex, 3 faces are meeting there, right? Okay. I suppose that is clear. You can in your room also 3 faces. Yes. Is it sum or product? Product, sorry. That was just a silly question, right? On each corner, product of the faces, product of the number. Okay. Yeah, product. Yeah, so written the question incorrectly. Product of the faces meeting. That's why. Yeah, meeting there. Otherwise, yeah. So I'll just number the vertices.
Sir, we can write any integers on the faces.
Yeah, any positive integer on the faces to begin with, but finally it has to satisfy this condition that it's, after all this is 2004. Should I have numbered the faces? Fine, let's leave it. Probably would have been better to number the faces because eventually, but never mind. So we have these numbers, right? So face A, face B, face C. Which one you'll call VCD, that's up to you. Okay. This is we have to find. Right? So face A is some face B is some face, C, D, E, F. It won't matter. So anything you can. And you can just call it ABCD. You don't have to call it F. Yeah, they are not said distinct. It is just positive integers. So can you understand then what is this corner thing? Right, from here, there are 6 faces. Maybe I'll say a little bit here. So I mean, so it will matter which ones you call A, B, C, D, right here. So let's see. So there is this face. So A, let's say A is 1, 4, 5, 8. You understand? 1, 4, 5, 8, that face, right? Formed by those vertices. Let's say that is A. Now you see this face and yeah, similarly, let me label it 1, 4, 3, 2. You understand? And then C is the behind one. 2, 3, 6, 7. Okay. And then this can be naturally be the bottom one. Okay, this is given. Any problems? Right? This is what we have to find. But you see, which faces are going to meet at the vertex 1? Now tell me. Right? Obviously, you will see that this 2, right? And this 1, I mean, anything that has 1. Is that right? Yeah. Anything that has 1 is going to meet. So it will be this one. These 3, right? Fine. So we will have this A, B, F. I mean, no, I'm not writing F, A, F, B, F. Maybe I'll write. You have F of A, B, F. Right. This will be the, sorry, not like this. F of A times F of B times F of F. these three faces will meet at the vertex 1, so their product. Similarly, you will have 7 other products. How so? Can you say about 2? Anyone? Which ones will meet at 2? Well, obviously those that contain 2, right? And this last one. So it will be F, B, C, F. So again I am right. Maybe I will write it as FC. Now tell me about 3. Hey, no one is saying anything. What happened? About 3.
F of B, F of C, and F of E.
Right? Yeah, BCE. So yeah, it's not, I mean, it's not following that any pattern, but you will see there will be something. So B, C, and E. And the point is that it will go like this, and there are 5 more. And that thing is totally 2004. Okay, so see, let's try to simplify, right? So there are these 6 numbers, right? And there are these 8, yeah, 8 numbers here, right? So my question is, maybe I'll create some space. Maybe I'll erase. I want to simplify a little bit. There are 6 numbers to begin with, right? And now we are forming 8 numbers, and we have 3 in each, and we are using 3 of them in each. So in total, we are using 24 of them, right? In total, we are using 24 of them. So how many times are we going to use each of them? Each face, right? There are 6
4
faces, right?
times.
Exactly, right? 4 times. That is the point, that each face is going to be used 4 times. Okay, so it's like you have X, Y, Z, W, T, U, V. And then all you have to do is just, if you just write it like this, Y, Z, W. Well, no. So if you, let us see what you get if you just write it like this. But it's clear, right? Each phase here you're going to use 4 times. Okay. Let's see if that is what happens if I just write it, in cyclic order. W, T, U. Well, it will not happen, I think, because this way is just using 2 times. T, U, V.
Sir, can we say that if you take any two adjacent sides like BC, then you will get 2 different corners from that, like how we got BFC and sorry BCF and BCE, like the top and the bottom.
Sorry. So you're saying if you fix 2 faces.
Sir, I meant that if you take any two adjacent sides like
uh,
BC, then 2 corners will be formed. One will be with the top and one will be with the bottom.
if you take 2 faces, then 2 corners are formed like that. Yes. Yeah,
Yes, sir.
that's
So
right.
then,
That is right. So maybe you can use all that to simplify this thing, right? UVX. Let us. That is a good idea, I think. Each one of them. So currently everything is appearing only once. Yeah, that is one way, but I am trying to.
Sir, each face appears 4 times, so the sum of all the faces should be 501, right?
501. 2004 is the sum of the product. No, why should the sum be 501?
Oh, sorry, I made a mistake.
No. Right. Here you see the way I'm writing it, it's coming 3 times. Right, everything is going to come 3 times. The W is coming 3 times. Obviously, maybe I have to write more. V, X, Y. Yeah, one more. Now you see that everything is coming 3 times. So this is not the right way to, write it. Then you have to write this big expression and then you have to think. Now let us see. So what Aparna was saying, if using that we can simplify something. This one doesn't seem to work.
Sir, when I wrote it, I saw that A was common in 4 terms and C was common in 4 terms.
Yes, yeah, because everything is coming 4 times. Right, that's right. So A was common in 4. So let us see. So if you take the face A, then it is common in 4 terms. Yeah. So is there a natural way to talk about those 4 terms? So once again, take A. Then it is a part of 4 corners, which we have also said in the other way. 4 common in 4 terms, and in those 4 terms, one, so this, no, sorry. One second. Yes, and those 4 terms will be like this. So what I'm trying to say is that when you take a face, let's say you take the front face, right? This 1, 4, 5, 8, right? So that is in this calculation, that is going to come in 4 terms, right? Because it is associated with 4 vertices, 1, 4, 5, and 8. So those 4 terms are, apart from the A, there will be 2 other faces featuring. Okay, right? A is no more there. One other face which is opposite to that will not feature. So 4 faces will feature, right? You see, so basically you have 4 variables, B, C, D, E, any 4 variables you take, and using them you have to create 4 terms. And the natural way to do is like this, right? Just cyclically B, C, C, D, D, E, and then E back to B. Okay, right? So is that correct? Is that making sense? Right? I'm trying to say is that, like, similarly when there is B, right? So like A is opposite to F. Okay, so you have fixed this. Okay, and so no, so then B will be opposite to what? That is the question. Can you say? So B is not opposite to C, right? B is not opposite to E. B is not opposite to A. And B cannot be opposite to F as well, right? Because A is opposite to F, so F is opposite to A. So B has to be opposite to D, right? So D will not come in that, right? So this will hopefully look something like AC. Yeah, but there is a dilemma, there is a problem. I mean, but the point is, if one arranges things properly, then maybe one can say CE.
Sir, if we arrange it in this way that 1458 is A, then 4365 is B, 3267 is C, and 2178 is D, and the other two bottom and top is E and F.
Huh? Right. Yes, we do get this thing, but no, that is right. But it's still, how will you use this to solve the problem? Is the thing, right? That is the problem. You see, I mean, it is still
You
a
can't
problem.
take much things common.
Yes, right. Even if you, and that's why I'm not putting the effort into arranging it, because even if you do it, yeah, you can't take it common, you can't factorize it.
Sir, I could actually factorize it a bit, but
Right.
I don't
Will it, does it factorize, or because a bit
Sir,
factorize is different, huh?
Sir, when I took A common and I took C common in the other four terms, then I saw that the what I say, the two multiples were common.
No, C common in the other four terms, you mean these kind of things. But will C be common in the other four terms? Are you sure? No, no, because C will be opposite to something, right? And then it will not come in that, right? I doubt that. Yeah, this is a question. Yeah, maybe we have to not think so much into this. In the sense, what I am thinking is that we have to think in a more, not look at all the details, otherwise it gets complicated. The point is that you have these things, these kind of things, right? And each thing is going to come 4 times. We know that. If you look at this, no, the idea is that these are integer numbers, right? And if you have these integer numbers, right, and you have products, and you have 8 terms, right? Then the sum being 2004 seems to be very less. Do you see what I'm trying to say? Right? I mean, imagine that if no, that would be like, if suppose every phase was 10, right? If every phase was 10, then what will the sum be? It will become 1000 into 8. If every phase was 10, that would be way more than this, right? If every phase was 5, then you will have 125 into 8, which is 1000. But then this is possible, right? Every phase can be 5 is still a lot of cases to check.
Sir, I actually could factorize it now.
Oh, yes. What is the factorization?
Sir, I'm getting A plus C into B plus C into E plus F.
Okay, that is a nice one. A plus C
Into B plus D into E plus F.
B plus C
D.
D. Okay.
Into E plus F.
Badhiya. This is correct. Yeah, I don't know what I was avoiding. Right, good. Very good, Aparna. Right. So now yeah, and this might just be correct. And it is, yeah, it looks to be the correct thing. Good, good, good. Yes. See, yeah. So I will say about this more the next day, but I think I don't have to say anything to solve the problem. First step is, which is a homework, is that prove this factorization. Prove the factorization. Okay. Aparna, you guys, if you have done it, you try to write it, means so that you can tell us next time if. Okay. Ishana, you'll do this? Okay. Try to prove that it factorized.
Yes.
Like obviously this AC is up to you. That will depend on your labeling. I will probably get A plus F. If F is opposite to A, then I will get A plus F. Right?
Yes, sir.
Yeah. And that's a different thing. But the fact that it factorizes like this, it certainly I can say it looks correct, even though I didn't come up with it. So you do this, and then you try to complete the problem from here, which is not very difficult now. Yeah, factorization is the way to go. I noticed that because the bounding was not working, right? It could be 5, 7, so you can't try so many cases. So it had to factorize. Yeah, so this factorization is not difficult, only that I don't know, I was avoiding the writing everything, and yeah, if you write everything, it will factorize. Good. I did not know this. This is a nice factorization. I will think about why this holds. Okay. I mean, in a different, maybe give some sort of a, yeah, good reason. So try to prove this factorization, and then we are done. Yeah, it obviously has to be the correct. This has to be the correct factor. So A is opposite to C, B is opposite to D, and is opposite to F. This is the correct factorization. Aparna, can you say that in words if it's possible? Why this is the factorization?
Sir, what I did was, in 4 terms there was A common, and in 4 terms there was C common. So when I took A common, like A out of it, so I got uh, 4 terms, which was same when I could took C common in the other 4 terms. Like
Hmm. Okay.
uh,
Okay. Yeah, that's I understand.
the
That is
part the part inside the bracket was same, so I wrote it as A plus C into that.
okay. I have not completely understood, but yeah, you are saying it in the algebraic way. There is a direct way, will be a more novel way to see it. Maybe I will try to say it next time. Okay. Yeah, it's the way the multiplication is in some way. But okay, I'm not able to completely frame it now, and I'll say it next time. Okay, so do this. It's fine, and then we'll meet tomorrow at 9:30, and yeah, we'll continue. Okay.
Sir, will we discuss the RMO questions only, or will it be some other?
No, tomorrow we will do more geometry. We were doing cyclic quadrilaterals and so on, right? So we will do that, and maybe we will pick two. Yeah. So how about this, right? I mean, to try RMO 2000 from 2001, 2, 3. Try the geometry questions if you get the time. You'll see all of them use these circles and those theorems we prove. The triangle geometry, you know more well, right? But you'll see you'll use the circle things, tangents and so on. Let's see if you just give it have a look. We will see. I'm not completely, I don't know. Yeah, maybe it's better to do at least one question, geometry question from RMO, and discuss a bit more theory. We are lacking a little bit, but yeah. Okay. So tomorrow 9:30 we meet. Yeah. Take care. Bye.
Yes.
Bye.
Bye, sir.